Ozonolysis of alkynes, otherwise known as the oxidative cleavage of alkynes. So if we take an alkyne, a molecule with a carbon-carbon triple bond, and we treat it with ozone, O3, followed by an aqueous workup, so adding water, what we will see is this will cleave the triple bond while oxidizing both of those carbon atoms to carboxylic acids. So here is the R group, and then the carbon it's attached to will become a carboxylic acid, and we will see the same thing on the other side of the alkyne. In this example, I drew an alkyne that is inside the chain. It's not at the end of the chain, so this is an internal alkyne. So when you do the oxidative cleavage of an internal alkyne, you will break that carbon-carbon triple bond and you will form two carboxylic acids. If you do this same reaction and you use, instead of an internal alkyne, an alkyne at the end of the chain, which is known as a terminal alkyne, so same reaction conditions. In the first step, ozone. In the second step, water. So this will also do an oxidative cleavage. So we will end up with a carboxylic acid. And at the terminus of the chain, we will initially get a carboxylic acid. That carbon is bound to a hydrogen. And then here is the carboxylic acid. This formic acid is not stable, so this is an intermediate. And this decomposes to form carbon dioxide. So if you do the oxidative cleavage of a terminal alkyne, you will get a carboxylic acid from the side where your alkyne has a bond to carbon. And the terminal carbon of the alkyne will become carbon dioxide. So let's look at one or two examples where we have something besides R. So we draw an alkyne. This is an internal alkyne. We have treating this with O3 followed by water. And I am going to number the alkyne chain so we can keep track of these carbon atoms. So what we will see in this reaction is that we will oxidize and cleave this bond. So we will end up with carbons 6, 5, 4, and 3. 6, 5, 4, and 3. That will be one carboxylic acid. And then carbons 2 and 1 will be the other carboxylic acid. So the numbering system that I have here is not the correct numbering system for the carboxylic acids. It's just keeping track of where these carbon atoms end up in our two carboxylic acid products. And let's look at an example with a terminal alkyne. So here is a terminal alkyne. It's terminal because it's at the end of the chain. I'm going to number that carbon chain. So if we do an oxidative cleavage here, same reaction conditions, ozone followed by water. So we will end up cleaving this bond, oxidizing carbons 2 and carbon 1. So we will have a 4 carbon atom carboxylic acid, and the 1 carbon atom carboxylic acid ultimately becomes carbon dioxide. So again, I am numbering to keep consistent with what we have here. So we see where these 5 carbon atoms are. Carbon 1 is in that carbon dioxide. Carbons 2, 3, 4, and 5 are part of that carboxylic acid.